Welcome! Today we're diving into the calculation of standard deviation. Understanding this fundamental concept is essential for analyzing data variations. Let's break down what standard deviation represents in statistics. The standard deviation quantifies the amount of variation in a dataset. A low standard deviation means that data points tend to be close to the mean, while a high standard deviation indicates greater spread. Understanding the standard deviation helps in comparing datasets and understanding how different they are from each other. This can guide decision-making in fields like finance, science, and social research. In real-world scenarios, standard deviation is applied in various fields. For example, investors use it to assess the risk of investments, while educators analyze test scores for validity. Let's explore the formula used to calculate standard deviation step by step. Understanding this formula is the key to performing accurate calculations. To calculate the standard deviation, we start by determining the mean of our dataset, which gives us a central value to compare our data points against. Next, we subtract the mean from each data point to find the deviations. This step is essential to understand how much each value differs from the mean. Now, let's square the deviations and sum them up to understand the overall variance in our data. By squaring each deviation, we ensure that negative values do not cancel out positive ones. This gives us a clearer image of the spread in our dataset. After squaring the deviations, we add them all together. This total helps in determining how far away our data points are, in a squared sense, from the mean. In the final steps, we'll see how to derive the standard deviation from our previous calculations and interpret its significance. To calculate the variance, we divide the sum of squared deviations by the number of data points minus 1. This adjustment is called Bessel's correction, and it's vital for unbiased estimates. The final step is to take the square root of the variance. This brings us back to the original data units and gives us the standard deviation. Interpreting the standard deviation allows us to gauge the variability of our data. A smaller standard deviation suggests our data points are close to the mean, while a larger value indicates more spread. To summarize, we learned about the formula, the steps for calculations, and how to interpret results in the context of real-world data. This knowledge is practical for statistical analysis. Thank you for joining me today. I hope this walkthrough of standard deviation calculations has enhanced your understanding of this important statistical concept.